Let's have the solution to example 73. Use the method of sections to determine the force in member DF of the truss in problem 72. State whether this member is in tension or compression. So here is problem 72 in this series of examples. By symmetry, again, we remember that the reactions, vertical reactions at A and H are each 1,200 pounds. And the horizontal reaction at H is 0. So since we have to consider method of sections this time, we section this panel here so that we can determine the force in member DF by summing up moment about E, considering all forces to the right of that section 1-1. So considering section 1-1, these are the forces or members that are cut by this section, so they are represented by these arrows. And since we want to sum up moment about E so that these two members are not involved in the moment equation, then I will not name these members. Anyway, they are not part of the moment equation. We sum up moments about E. So this is FDF, and the angle that FDF makes with the horizontal is arctan of 2 plus 1/3 over 8, and it was 16.26 degrees. So the horizontal component is leftward, the vertical component is upward. We always assume the member is in tension. So summation moment about E equals 0 considering all forces to the right of this section. So counterclockwise positive. So we have FDF cosine of 16.26 degrees. The moment arm is 6 feet. That's the moment of the horizontal component plus FDF sine of 16.26 times moment arm is 8 feet. Then plus 1,200 times 16 feet. So FDF sine of 16.26 degrees times 8 plus 1,200 times 16. Then equals clockwise moment 600 times 8 plus 300 times 16. 600 times 8 plus 300 times 16. So only FDF is the unknown here. Computing for FDF, FDF is negative 1,200 pounds, or FDF is 1,200 pounds compression, which is the same answer as that of method of joints. Another way to solve for FDF is by applying principle of transmissibility of a force, so that we only have one term, one component, the horizontal component. I move FDF at D. We can do that by principle of transmissibility. There are two components, horizontal and vertical, but the vertical component passes through E, so only the horizontal component is being considered, which is FDF cosine of 16.26 degrees. And the moment arm is 2 1/3 plus 6 feet. So summation moment about E, another solution, equals 0. So counterclockwise positive, FDF cosine of 16.26 degrees times quantity 2 plus 1/3 plus 6, 4 inches is 1/3 of a foot, plus 6, then plus 1,200 times 16, then equals 600 times 8 plus 300 times 16, which is the same. So solving for FDF will give us the same result of 1,200 pounds negative or 1,200 pounds compression. So that's it for this problem. So for this problem here, use the method of joints and verify by the method of sections the stress in member CF for the truss shown below. So here is the truss, a cantilever truss. So we are required to compute for the member force of CF. This is CF here, and we apply first method of joints. And before we can apply method of joints, we look at joint G. At joint G, we have three members, two are collinear, therefore this is unloaded, therefore CG is 0 by case 2 of identifying 0 force members. Then we proceed to joint C. At joint C, since CG is 0, there are three members rather. CF is unique, and therefore our direct equation to solve for CF is summation forces y equals 0. Now, the problem is, what is the inclination or angle that CF makes with the horizontal before we proceed to joint C? So if we analyze joint C, these are the forces. We have two horizontal forces there, and this is FCF, and we plan to sum up forces vertical so that only CF and 12.5 will be involved. So since this is 2.5 and the truss is divided equally into three spaces, so that means the length of CG is 1/3 of 2.5, and the length of BF is 2/3 of 2.5. Now 2/3 of 2.5 is 2 times 2.5 over 3, or 5/3. Summation forces y equals 0, down positive. So the length of BF is 5/3. Therefore, arctan of 5/3 over 2 is equal to 39.806. So the angle that FCF makes with horizontal is 39.806. So that summation forces y equals 0, down positive. The vertical component of FCF is FCF sine of 39.806 plus 12.5 equals 0. So FCF is equal to negative 19.53 kilonewtons, or FCF is 19.53 kilonewtons compression. Now, by method of sections, we section this portion here, and there are three members cut by that section. The two meet at D, so we plan to sum up moment about D so that we can directly compute FCF. So this is the section 1-1, and we consider all forces to the right of section 1-1, and these are the cut members. So two members BC and GF rather, or FG, meet at D. So if we sum up moment about D, considering all forces to the right of this section, then only FCF and 12.5 kilonewtons, this 12.5 kilonewtons will be involved, because the moment of 12.5 kilonewtons acting at D is 0. So again, this is 39.806. FCF has two components, horizontal and vertical, but the horizontal component of FCF passes through D, so it has no moment about D, only the vertical component. So summation moment about D equals 0, counterclockwise positive. Vertical component of FCF, FCF sine of 39.806 times 2 plus 12.5 times 2 equals 0. So if you cancel out 2, this equation is the same as this if 2 is being cancelled out. Therefore, FCF is the same, negative 19.53 kilonewtons, or FCF is 19.53 kilonewtons compression. So that's it for this problem. Okay, for problem 75, a pitched flat roof is loaded as shown. Determine the force in members CE, DE, and DF. State the force as tension or compression. So again, if the force is positive, it is tension; if negative, compression. So this is the pitched flat roof truss. Since the loadings are symmetrically located, equally spaced apart also, then therefore the vertical reactions at the supports would be equal to, the total load is 1 plus 2 plus 2 plus 2 plus 1 is 8. Therefore, the vertical reaction is 4 kilonewtons at A as well as at I, and the horizontal reaction at A is 0 because there's no inclined load. So we section this portion, this panel here, and let's consider forces to the left of that section 1-1. So we name the cut members as FDF, FDE, and FCE. Now we can determine directly FCE by method of sections by summing up moment about D, so that FDF and FDE will not be involved in that moment equation. So to solve for the length of CD and EF, we have to apply similar triangles. So this is distance CD minus 0.46 as to 2.4 equals distance EF minus 0.46 as to 4.8 equals 2.62 minus 0.46 as to 9.6. So this CD minus 0.46 as to 2.4 equals distance EF minus 0.46 as to 4.8 equals 2.62 minus 0.46 as to 9.6. So computing for distance CD, it is equal to 1 meter. Distance EF is equal to 1.54 meter. So therefore, this is just 1 meter. So summation of moment about D equals 0, counterclockwise positive, we can now compute FCE. So FCE times 1, then plus 1 times 2.4 equals 4 times 2.4. So that's the moment equation solving for FCE. FCE is 7.2 kilonewtons. Since it is positive, it is tension. Then for we will not determine DE first. So if you want to solve for force in FDE directly, you may extend this FDF, line of action of FDF, and FCE horizontal. Then their lines of action meet somewhere here. Then find that point to directly compute FDE. But although that's another way, but I'm planning not to do that. Let's solve for FDF first by summing up moment about E. So to make the moment equation simpler, I use principle of transmissibility of a force. I move FDF at F. We can do that. So that only the horizontal component of FDF will have moment about E. The vertical component passes through E, so it's not involved. Now, the angle that FDF makes with the horizontal is arctan of 0.54 because this is 1 meter and this is 1.54. So the vertical distance from vertical distance between D and F is 0.54. Horizontal is 2.4. So arctan of 0.54 over 2.4, that would be equal to 12.68 degrees. So that angle is 12.68 degrees, arctan of 0.54 over 2.4. So this is the horizontal component of FDF by principle of transmissibility of a force, because we plan to sum up moment about E so that FDE and FCE will not be involved. Only FDF would be the unknown. And the vertical component is passing through E, so it's not involved in the moment equation. So again, distance is 1.54. Summation moment about E equals 0 clockwise positive. So FDF cosine of 12.68 times 1.54 plus 4 times 4.8. So plus 4 times 4.8 then equals 1 times 4.8 plus 2 times 2.4. So that's the moment equation. So therefore, we can now compute FDF. FDF is negative 6.390 kilonewtons, or FDF is 6.39 kilonewtons compression. Then for FDE, we have two options, summation forces X is 0 or summation forces Y is 0. So we only need one equation because only one unknown is left. So for the other static equation, then we'll just use that for checking if the answer is the same. So the angle here is 22.62 degrees, the angle that FDE makes with the horizontal. Arctan of 1 meter over 2.4 is 22.62 degrees. So summation forces Y equals 0 to make the equation simpler. So we have 4 kilo FDF, which is negative 6.39390 sine of 12.68. So 4 kilonewtons upward plus vertical component of the FDF is negative 6.390 sine of 12.68 equals 1 plus 2. So take note that we consider only forces to the left of section 1-1 equals 1 plus 2 plus the vertical component of FDE, which is going down, which is FDE sine of 22.62. So in this problem, only FDE is the unknown. So using the calculator, FDE is negative 1.047 kilonewtons. Then let's verify this value by using the other static equation, summation forces x equals 0. So we have FDE cosine of 22.62 plus FDF plus FCE, which is 7.2, plus FDF cosine of 12.68, where FDF is negative 6.390, then cosine of 12.68, that's the horizontal component, then no more because this is 0 equals 0. So solving for FDE, it is also equal to negative 1.046 kilonewton. So the very, very small discrepancy is due to the rounding off of the angles as well as the values of some of the forces. So therefore, they are practically equal. So I'll use the first result because we use this first. So our FDE is 1.047 kilonewtons compression. So that's it for this problem. Next, for problem 76, this is the truss given. From the given loaded cantilever truss, compute the following: the external reaction at F, the stress of member BC, the stress of member DE. So when say stress, that's the member force labeled as tension or compression. Now, DE is a truss member, therefore it is a two-force body, and therefore its force is along DF. Therefore, the reaction at F is also the force in member DF. So we indicate, these are the expected reactions at E. We indicate FDF equals RF also. So since these are equilateral triangles, the measure of these angles here are 860 degrees, as indicated in the figure. So 30 plus 60 is 90. Therefore, the line of action of FDF or RF is perpendicular to DE, and the moment arm is X. So we can solve RF directly by summing up moment about E equals 0, clockwise positive. So RF times X, that's clockwise, equals counterclockwise moment. 37 times X equals 37 times X plus 24 times 2X. So cancel out X, then we can solve RF equals 48 plus 37, 85 kilonewtons. Next is the stress in member BC. This is member BC here, and you can use method of joints, method of sections, or whatsoever. But the best way is using method of joints. We section this portion. We consider all forces to the left of section 1-1, and the forces involved are FBD, which is horizontal, FBC, which I name FBC because this is the required force, and this member here, FAC, which I do not name because our plan is to solve for FBC directly by summation forces Y, and these horizontal members are not involved in that equation. So summation forces Y equals 0, downward force positive. So FBC, the vertical component of FBC is FBC sine 60 plus 24. Those are the only forces involved to the left of that section 1-1 equals 0. So therefore, FBC is negative 27.71 kilonewtons, or FBC is 27.71 kilonewtons compression. Then for the force in FDE, we consider section 2-2 and to the left of section 2-2. So this is the original figure, is section 2-2, so that our plan is to sum up forces Y again equals 0. The member forces involved are FDF, which is already found, 85 kilonewtons, and this is FDE, and this is the other cut members, FCE. but FC is not involved if we sum up forces y equals 0. And considering all forces to the left of section 2-2. So 85 sine of 30 equals FDF sine of 60 plus 24 plus 37. So 85 sine 30 degrees equals FDE sine of 60 plus 24 plus 37. So solving for FDE is negative 21.36 kilonewtons. So that means FDE is a compression member, 21.36 kilonewtons. So that's it for this problem. So for the last problem for this series of problems, this is similar to May 2013 board exam. A transmission tower is loaded as shown. Assume roller support at A and hinge support at B. Determine the reaction at A. Determine the total reaction at B. And determine the force in member EJ. This is the figure. So because this is pin support and this is roller support, we expect vertical reaction at A. R sub A is upward. And summation forces X, 3 plus 5, 8 plus 7, 15. So the horizontal reaction at B is 15 kilonewtons rightward, and the vertical reaction is downward. So the vertical reaction at B is downward, and it is expected to have the same value as RA. So to solve for RA, we sum up moment about B considering the whole system, equals 0, clockwise positive. So RA times, this is 1.8 plus 1.5, 3.3 plus 1.8, 5.1. RA times 5.1 equals 7 times 1.8 plus 5 times 3.6 plus 3 times 5.4. Solving for RA is 9.176 kilonewtons upward. Since it is reaction at A, then it is upward. Without this direction, then it is wrong because we are looking for reaction at A and reaction is a vector. So it should be provided with direction. Then for reaction at B, By is also 9.176 downward. So therefore, we can now compute the magnitude of the reaction at B. Square root of 15 square plus 9.176 square. So the magnitude of RB is 17.58 kilonewtons. It is directed down to the right. Now, the angle that the reaction at B makes with horizontal is arctan of By over 15. So tangent of theta B equals 9.176 over 15. So theta B is 31.46 degrees. Therefore, the total reaction at B is 17.58 kilonewtons directed down to the right with an angle of 31.46 degrees to the horizontal. So that should be the reported answer. Then for the force in member EJ, this is EJ here. Actually, this is a K-truss. It is just flipped. So we cannot directly compute for EJ by all methods. So first we consider the forces above this section 1-1. So I introduced that section 1-1. That's the technique for a K-truss. So that the cut members are shown. We only consider forces above that section, not below. So there are 4 members cut, CJ, DJ, and DF, as well as FCE. So I only name FCE because we want FCE to solve for force of member EJ later. So because these 3 cut members meet at D, so it is best to sum up moment about D equals 0. But we must know the inclination of CE. So this is the equation. Summation moment about D equals 0, counterclockwise positive. So let's analyze the distance first. So take note that the length of CGH is 1.5, then the length of AB is 5.1. So 5.1 minus 1.5, that's 5.1 minus 1.5, that's 3.6 meters. So since there are three equal spaces, that 3.6 should be divided by 3, so 1.2. So the increase in length is 1.2. 1.5 plus 1.2 is 2.7. Therefore, this is 1.35 and 1.35. The angle that CE or GE makes with the vertical is arctan of 1.8 over 5.4, and that is 18.435 degrees. So therefore, by principle of transmissibility, I move FCE here so that the horizontal component passes through D, although you can just make it at E, but there are two components that have moment about D. So to simplify the calculation, I use principle of transmissibility. I move CE here, and this is the horizontal component at C which passes through D, so it has no moment. Only this vertical component has moment about D. Now, for the distance, again, since each length is increased by 1.2, 1.8 plus 1.8, 3.6 divided by 3 is 1.2. So 1.5 plus 1.2, the total length of EF is 2.7. Then let's divide it into 2, 1.35 meters each. Then 2.7 plus 1.2 is 3.9. So that means CJ is 1.95 and JD is 1.95 meters also. So therefore, the moment arm of FCE cosine 18.45 is 3.9 meters. So FCE cosine of 18.45 times 3.9, that's counterclockwise, and we consider forces above. So the moment of 5 is counterclockwise. So plus 5 times 1.8 and plus 3 times 3.6 equals 0. So solving for FCE, FCE is negative 5.352 kilonewtons. So having found FCE, we then introduce section 2-2, and additional members cut are EJ and this member here, FJ, but we plan to sum up moment above F considering forces above section 2-2. So forces involved would be FCE, FEJ, and the 3 kilonewton force only because the 5 kilonewton acts at F. We sum up moment about F. So again, FCE is just at E. There are two components, vertical, downward, and horizontal, which is leftward. The horizontal component of FCE passes to F, so we don't mind it. FEJ has also two components, horizontal, which passes to F, so don't mind, and the vertical. Only the vertical component of FEJ has moment about F. Now, what is the angle that FEJ or EJ makes with horizontal? It is arctan of 1.8. This is 1.8 over 1.35. So inverse tangent of 1.8 over 1.35 is 53.13 degrees. So summation of moment about F equals 0, counterclockwise positive. I'll begin with FEJ. The vertical component of FEJ is if EJ sine of 53.13 and moment arm is 2.7. Then plus the vertical component of FCE. Remember, the horizontal components pass through F, so they are not involved. So the vertical component of FCE is negative 5.352 cosine of 18.435, and the moment arm is also 2.7. Then plus 3 times 1.8 equals 0. So solving for FEJ, FAJ is equal to 3.847 because it is positive, so it is tension. So that's it. That's the solution to this problem. It's a bit tedious, but I hope that you were able to understand the explanation. So it's a matter of trigonometry and inclination actually, and a little analysis on the moment arms. So that's all for this problem.